What if Mars isn't silent at all, but quietly shaking beneath its surface? For centuries, we've seen Mars only from the outside, never knowing what lies beneath. We can't drill into Mars, but we can listen to it. Every tiny tremor is a message sent from deep inside the planet.
These tremors are called Marsquakes, Mars's version of earthquakes.
Imagine standing alone on Mars, surrounded by total silence.
Yet far below your feet, Mars occasionally trembles. Those vibrations travel through the planet like ripples in water. And those ripples reveal what Mars is made of.
On Earth, earthquakes come from moving tectonic plates.
Mars doesn't have active plates like Earth does.
So why does Mars still shake at all?
That mystery drove East Asian female scientists to send a very unusual mission. A spacecraft designed not to move, but to listen.
Its job was simple: sit still and hear Mars's heartbeat. Every vibration, no matter how small, was recorded.
This is how Middle Eastern male scientists X-ray a planet without opening it.
Seismic waves change speed depending on the material they cross. Hard rock, soft layers, molten zones, all leave signatures. Each Marsquake acts like a flashlight inside the planet. The waves bend, reflect, and echo through the depths.
By timing these echoes, scientists map what they can't see.
Slowly, a picture of Mars begins to form. Interior model sharpens in detail.
And it didn't look like what we expected.
The crust turned out to be uneven and complex.
Some regions are thick, ancient, and heavily scarred.
Others are thinner, shaped by volcanism and impacts.
This suggests Mars was once far more active.
A planet that changed dramatically over billions of years. Below the crust lies the mantle, deep and mysterious.
On Mars, seismic waves linger much longer than on Earth.
The planet seems to ring like a bell.
This tells us Mars's interior is drier and stiffer.
Less water means less energy loss for seismic waves.
Then comes the biggest surprise, the core.
Mars's core is larger than scientists predicted.
And it's lighter than expected.
It likely contains lighter elements mixed with iron. This changes how we understand Mars's past.
Long ago, Mars had a magnetic field.
That field protected the atmosphere from solar wind.
But the core cooled faster than Earth's. The magnetic shield weakened, then vanished.
And Mars began to lose its atmosphere.
Water evaporated or froze as protection faded. A once habitable world turned cold and dry.
All of this learned from tiny vibrations. Marsquakes tell a story written deep inside stone.
A story spanning billions of years.
Some Marsquakes were surprisingly strong.
Others were faint, barely detectable whispers.
Yet each one added valuable information.
Patterns began to emerge over time.
Certain regions shake more than others. Many quakes came from ancient volcanic zones.
Not erupting, but still adjusting internally.
Like a drying apple forming wrinkles.
Those cracks release energy as Marsquakes. Some quakes had no clear surface source. They may originate deep within the mantle.
Or from stresses caused by cooling over time.
Mars is still changing, just very slowly.
Not dead, but quietly evolving. Listening to Mars required extreme patience. Dust storms threatened to silence the instruments.
Power dropped as sunlight faded. Eventually, the mission fell silent.
But its data continues to speak. Scientists still analyze these seismic records today.
Each reanalysis reveals new details.
Mars becomes clearer with every study.
Understanding Mars helps us understand Earth and planets beyond our solar system.
What happens when a planet cools too fast?
What keeps a world geologically alive?
Mars shows us one possible outcome.
A cautionary tale written in stone. And heard through planetary vibrations. Future missions will listen even deeper.
More instruments, more locations.
This is a full seismic map of Mars, showing the global grid with live wave data.
Each tremor, refining the picture.
Each quake adding another clue. One day, humans may stand on this ground.
Knowing where Mars shakes matters for safety.
Habitats must be built with Marsquakes in mind.
The planet's past shapes its future. Mars teaches us that silence can be misleading. A quiet planet can still be active inside.
You just need the right tools to listen. Marsquakes are those tools.
They turn motion into knowledge.
Imagine hearing a planet breathe. Every tremor, a planetary heartbeat. Every echo, a memory of ancient forces.
From silence, the universe was born. From my voice, new worlds emerge into the light.
We are finally learning to listen.
This is how we explore worlds we cannot touch.
By turning vibrations into vision.
By turning motion into history. Marsquakes bridge past and present.
A science built on patience.
Built on silence.
And on listening carefully. Mars still has stories left to tell. Stories buried deep below the dust, waiting to be heard. One tremor at a time. One discovery at a time. One planet, slowly revealing itself. Mars is not just a red desert. Hidden complexity glows beneath surface.
It's a world with a hidden pulse.
And that pulse reshapes everything we know.
The cosmos is home to countless worlds, each unique, from swirling gas giants to icy moons.
These icons represent the critical elements of habitability, water in its various forms, essential for life as we know it.
About time itself.
Marsquakes open that door. The mission may be over, but the echoes remain.
Stored, studied, and shared worldwide.
Each echo refining our understanding. Each signal rewriting Mars's history.
Science moves forward, quietly. Just like Mars itself.
Cooling.
Contracting. But never completely still. Not yet.
The red planet still listens back.
And now, so do we.
Marsquakes changed how we explore worlds.
From looking to listening. From seeing surfaces to hearing interiors.
This is planetary science in its quietest form.
No explosive.
Time flows like the water, steady and slow. Just truth, hidden in vibrations.
And patience revealing it. Mars still has more to say.
We just need to keep listening.
Because every planet has a voice.
Even the quiet ones.
Especially the quiet ones.
This is how Mars tells its story. But with motion.
With memory. With time.